So now that you've had a little experience with logs, we're going to use that experience to help us solve exponential equations. This is when we want to move x to the front of a problem because x is in a position where we'd rather that it wasn't. Okay, we want to move things to the front. Using that property that moves powers to the front. All right, let's start with a nice, this is going to be like the questions that are at the beginning. I want you to start with ones that kind of warm you up a little bit. All right, something like this. 3 to the x equals 15. Remember, to solve means to get x by itself. All right, we want to get x by itself. Where is x right now? It's in the exponent. We need to move it to the front. What is the only legal way to move an exponent to the front? With a log. Okay, logs move things to the front if we need to. Okay, so we are going to do a log, but we got to do it on both sides. Okay, all right, so you have your choice of different logs to choose from. I always just recommend choosing natural. Okay, that is what I have found to consistently be the easiest, is to stick with natural. Okay, so let me show you. So we're going to do natural log on the left and natural log on the right. Just don't forget to do it on both sides. Don't do it on one side but not the other. So that allows me permission to bump that x out to the front. So x goes in front of ln 3. And now, how do I get it alone? Well, x, what's real tiny? What's between x and the ln 3? A dot. What does that dot mean? Okay, how do I get rid of that then? I can divide all of ln 3. Okay, grab your calculator out, type in ln 15 divided by ln 3 and get an answer. Does anybody have that? Say it again. Okay, is anybody else like? Okay, let's try another one. Let's do something similar. Okay, where's the x? Okay, in the exponent, where do I want it to be? In the front. How do I make that happen? With an ln. Okay, so I'm going to put an ln. Now, 9 is one of those numbers you need to think about. What is 9 actually? Okay, so let's replace 9 with 3 to the second. Yeah. Okay. Because now I can kick two things to the front. What gets kicked to the front on the left? What gets kicked to the front on the right? Okay, so I'll have x kicked to the front of ln 3. And I'll have 2 kicked to the front of ln 3. How do I get x by itself? Divide by ln 3. And what happens? You don't need a calculator. Don't grab your calculator. What happens? The ln 3's reduce, and I'm left with x by itself and 2 by itself. Okay.
It's going to be like a square root. No, don't get food. I'm trying to help you.
Okay. 3 parentheses 10 x plus 2.
There you go.
Okay. All right. What's our first legal move? Divide by 3. I can't have anything in front of those parentheses. Okay, I cannot have anything in front of the parentheses, so that gives me 9. Okay, where's the x? in the exponent. Where do I want it to be? In the front. How do I make that happen? With an ln. So I'm going to put the ln on both sides. And I'm going to change my 9 to 3 squared. So that kicks the x and the plus 2 to the front. And when you kick two things, you really should put parentheses around them in front of ln 10. And it kicks the 2 in front of the ln 3. I want to get x by itself. What do I get rid of first, the 2 or the ln 10? ln 10. Okay, how do I get rid of it? I divide. So then I'll have x plus 2 by itself. On the other side I'll have 2 ln 3 over ln 10. So I divided to get rid of it. And then we subtract the 2. 2 ln 3 over ln 10 minus 2. That's called the exact form. If they say you're allowed to use your decimal and get it to the nearest thousandth, then you type that into your calculator, get the decimal, and then tell me what it is. Yeah, Garrett. So we're just going to keep going with problems that are similar to the ones you'll see in your homework. How about 20, parentheses, half to the x over 3 equals 5. Okay, divide by 20. Good job. All right, divide by 20. What will that give me, Aaliyah? No decimals. Okay, 5 over 20. What does it reduce to? 1/4. Okay.
Wait, what? Hold on, where did you get 1/4 from?
I divided 5 by 20.
Oh.
Okay. All right. Now where's the x? In the exponent. Okay, I want it in the front, so I'm going to use an ln.
Why can't you use a log?
You can use a log if you want. I just find in my experience, natural log is a log. The ln is a log. A regular log. Now remember how we took the 9 in the last couple problems and we turned it into 3 squared? What about 1/4? Because 4 is something, right? Isn't 4 something? 4 is 2 squared. What's 1/4? How do we get the 1 over? Okay. 4 negative 1, or better even, 2 negative 2. That's better. Okay, 1/4 is 2 negative 2. What about the 1/2?
1 negative 2?
Not 1 negative 2.
Negative 2, 1?
2 negative 1. So what can we kick to the front on the right-hand side? On the right-hand side, what can we kick to the front? Negative 2. What can we kick to the front on the left-hand side? The negative 1 and the x over 3. So it's negative 1 times x over 3 times ln 2. I can kick both those to the front. And remember, now my job is just to get x alone. Okay, divide both sides by ln 2. That's awesome for me because the ln 2's will reduce. That will leave me negative x over 3 being equal to negative 2. And if you want to put negative 2 over 1, then you can cross multiply. If you put negative 2 over 1, then you cross multiply. Negative x equals negative 6, so positive x equals positive 6. That was one of the harder ones. That would be like the questions 1 to 2. Okay, What are we on, example 4? No, example 5? All right. 2.13 to the x equals 5.4. This is back to a fairly easy one. 2.13. Where's the x? In the power. Where do we want it? In the front. How do we make it happen? With an ln. Okay, ln 2.13 to the x and ln on 5.4. Okay, my experience shows me most people, the most common mistake is to forget the ln on both sides. Kick the x to the front and then use division. So x is the ln of 5.4 divided by the ln of 2.13. Yeah, unless they say put it into a decimal. If they say round your answer to the nearest thousandth, then grab your calculator and do the rest. But notice I didn't use my calculator up until that point at all. The calculator really only gets used at the very end, if directed to. Okay, how about 5 minus 4e to the negative x equals 3. Okay, legally, what do we get rid of first? How do I get rid of the 5? Subtraction. That leaves me with negative 4. E to the negative x equals negative 2. Next thing to get rid of, the negative 4. When I divide by negative 4, negative 2 divided by negative 4, 2 negatives make a positive. So I get 1/2. And then you say, okay, where's the x? It's in the exponent. Where do I want it? In the front. How do I make it happen? ln. So ln on both sides. Kick the x to the front. Negative x, actually, to the front of ln e. You guys remember Lenny from last year, right? Okay, ln e. They cancel each other out. ln and e are the only two things that cancel each other out. Okay, so that cancels out to 1. So I'm left with just negative x. I almost have x by itself already. And then x by itself would be x equals negative ln half. Okay, the next question, don't be afraid of how it looks. $250 over 1 plus 20 e to the 0.4x all equals 100. All right, don't be afraid of a problem that looks like that. We're not going to let it look like that for very long. What we're going to do when you see a problem like that is drop a 1 under the 100. Because what will that allow us to do right away? And then we don't have to have that problem look like that anymore. So when I drop a 1 under 100, now I'm going to cross multiply. Let's start with 250. That cross multiplies to 1. What does the 100 cross multiply to? The other denominator, the 1 and the plus 20. So I have to cross multiply to both of them. So 100 cross multiplies to 1, that's 100. But when 100 cross multiplies to 20, we get 2,000 e to the 0.4x. Okay, but that's a way nicer problem to look at than the other one was. Okay, so that's the first legal move, is to cross multiply. Now, next legal move, subtract which number? The 100. That gives me 150 equals 2,000 e to the 0.4x. What's my next legal move? Divide by 2,000. 150 divided by 2,000, and that leaves me with e to the 0.4x. You should reduce the 150. They clearly both have zeros, so I can reduce the zeros. And that leaves me with a 15 and a 200. So a 5 goes into both of those. So it's 3 over 40 equals e to the 0.4x. Okay, I've gotten rid of everything I can get rid of. Now I need to kick that 0.4x to the front. So I'm going to use a logarithm on both sides. That logarithm will allow me to move the 0.4 to the front so that I can solve for x. So I have ln of 3 over 40. Notice I still haven't used my calculator, a stitch. 0.4x equals ln e, and there's our friend Lenny. Natural log and e, when you get to just natural log and e left, those two things cancel each other out. So we're left with 0.4x. So we almost have x all by itself. And to get x by itself, I'll do the last division, which would be 3 over 40 divided by 0.4. And then if the calculator permits you to put that into decimal form, at that point, it's at the very end, and only at the end do you grab your calculator. Shouldn't really be using it in between.